Hello everybody, we are going live again, this one unscheduled, but you can look forward to Monday, Wednesday, and Friday live streams at 2 p.m. Today, I just had some books that I really wanted to read with you guys. So we're going to start with a chapter from The Story of Science, and then we're going to go to a Lift the Flap book, The Periodic Table. Now, I've been working all morning on continuing to upload all of my streams to my YouTube page, so you can find that link at my website, www.bethescientist.com, as well as right here on my Facebook page. So, without further ado, let's get started. If you join us a little late, that's okay. You can always rewind, hit that pause button, which is two lines that look a little bit like this right next to each other, if you want to take a look at the pictures a little longer. Both of these books are Usborne books and can be found at my aunt's website, azbookbuddy.com. So, shout out to Aunt Julie. Okay. So, we've read a few different chapters of The Story of Science. This is what the title, the cover of it looks like. And one of my favorite parts of these types of books is that we can open the page to the table of contents, which looks a little bit like this. And it will tell us where each part is located in the book. So the topics that we have are planet Earth, our place in space, physics, chemistry, numbers and counting, living things, the human body, and prehistoric finds. We've read about prehistoric finds, and we also read about our place in space. So I think we're going to start with living things. And it says that's on page 60. And I want to show you a close-up because these illustrations are just great. So we're going to start with that guy with the beard and the long list. Okay. So page 60. And when you grow up, you might have textbooks that kind of work like this too. You can look at a table of contents and flip to the right page. So, living things. And I'll show you the picture first, and then I'll show it to you again later. Oh, we got a little window light here. So, we're going to be talking about these two images. Classifying creatures. What do you call a small, furry, purring pet animal? Did you say cat? You got it. The domestic cat has hundreds of names and nicknames in many different languages, but scientists everywhere know it by the scientific Latin name Felis catus. I know about the cat in the hat, which I think in Spanish is La Chapeau. Write the correct translation in the comments if you're here, because I don't remember. It was a long time ago. So Aristotle, who's the guy with the long list and the beard, he made many lists of animals. For example, he described and named 116 species or types of fish. And again, that's this guy up in the corner. That's Aristotle. Aristotle was a really famous thinker a long, long time ago. Okay. Aristotle and Theophrastus is the next section. Ancient Greek writer and thinker Aristotle, with the beard, developed an early classification system. That means an easy way to label things around 330 BC. That was a long time ago. America wasn't even the United States of America yet, and there were still indigenous populations here. For example, he divided animals into those with blood and those without, and according to whether they walked on land, flew in the air, or swam in the water. Can you think of any animals that walk on land or swim in the water? hit that pause button to come up with a few ideas. Aristotle's student, Theophrastus, wrote 2 books on plants, dividing them into groups according to where they grew, their size, and what they were used for. Can you come up with any examples of plants? Maybe plants that can grow in your backyard, and maybe plants that you've seen in a museum. Okay, so now let's talk about a whole brand new system. Aristotle and Theophrastus made a great start, but their categories didn't always make a whole lot of sense. For example, sardines, turtles, and whales all swim in the sea, but they breathe, feed, and have babies in totally different ways. So it looks like it's a good way to classify, but we can still get a little closer. In the 1500s, 1600s, and 1700s, people began exploring more and more of the world. And zoologists, that's a scientist that study animals, and botanists, that's a scientist that studies plants, discovered thousands of previously unknown species or types of things. They couldn't all fit into the old system, so people came up with new ways of classifying the living creatures. The biggest and most important system was invented by a Swedish naturalist named Carl Linnaeus, and a version of it is still used today. My friend Al from the Franklin Institute loves talking about classifying animals and knows a lot about it. So this is a picture of Carl Linnaeus in the corner there. And it looks like he's checking out different types of plants. And I see some of my friends are here. The light is pointing at my phone in a way I couldn't see when I was sitting back. I've got my friends, Kira and Lainey, and I see my mom's here, and my friend Dana. Excellent. Hey everybody, thanks for joining us today. Oh, poison ivy. That's a really great example of a plant that might be found in your backyard that you should not touch. My mom always said, shiny leaves of 3, let them be. Don't touch them. You'll get very itchy. Okay, so let's talk about Linnaeus's life. That's the guy who made that structure to classify animals. The family of Carl Linnaeus hoped that he would be a priest like his father, but he was so passionate about plants that they let him study science and medicine instead. Their family was poor, but Linnaeus's enthusiasm impressed many wealthy friends, people with a lot of money, who paid for him to study. Wow, that's amazing. Linnaeus loved writing long lists of living things and getting all the details exactly right. So here's the picture that we're talking about. There's Linnaeus and his tree, which he might have classified. Oh, hey Marcy and Isabel, thanks for joining me. You're gonna love this next chapter. My friend Isabel is a scientist that studies dirt. And dirt grows a lot of really cool things and serves as an environment for a lot of living things as well. Sometimes we say flora and fauna. So flora would be plants and fauna would be some sort of animals. Linnaeus' system of nature. Carl Linnaeus was born in Sweden in 1707, and he worked as a doctor and as a teacher of botany. That's plant science. He was fascinated with plants and discovered many different types himself, but explorers also sent him samples of plants and animals they had collected from around the world. Wow, let's think about that. Do you think that means that they were sending envelopes with different kinds of plants in it? I wonder if by the time they got to Carl, if they were dead. Because if I pick a plant and then just put it in an envelope, it can't live anymore. It's not connected to the roots. It doesn't have all that water going through it, and it can't photosynthesize or get energy from the sun. So that's something we can all think about. If anyone knows anything about this, you can write it in the comments. Throughout his life, Linnaeus worked on a new way of classifying living things. His method divided plants and animals into groups, and then split each group into smaller groups, and each smaller group into smaller groups, and each smaller group into even smaller groups. Instead of sorting them according to where they lived or their uses to humans, Linnaeus looked at their shapes and how they lived and had babies. He wrote his system down in his book, The System of Nature. It was first published in 1735, but he revisited it. That means he made changes and edited it many times. By 1770, it listed over 12,000 living things. Can you think of some living things and put them into categories? Maybe you can categorize them as animals you'd find in a zoo, animals you might find in your backyard, animals that live with us. I know for a lot of people, this could be a lot of different things, as some people might live on a farm, other people might live in a city. But see if you can practice classifying animals. So one more little section here, but first I'll show you the picture that goes along with Linnaeus. So that corner picture is Linnaeus. He's writing all those really, really long lists that you'll be working on. And he decided how to label all of these classifications or types. So for new names, and I'm going to show you the picture right after. Before Linnaeus, living things did have scientific names, but they were long-winded Latin descriptions. That means that the names were so long and so hard to pronounce that Linnaeus tried to fix it. Linnaeus invented the binomial system, in which each creature had a simple two-part Latin name. So, the word binomial means two names. The first name shows the family that the animal is in, and the second name shows the species. Can anyone guess what Felis catus might be? Write it in the comments if you have any idea. Felis catus. And then I'll show you a picture of what it is. Any guesses? Ooh, looks like I might be stumping people. Okay, Felis catus, meow, is a cat. So that very first word, Felis, refers to the family. So other animals in the Felis family might be big cats like tigers and cougars and lions. And the second name shows the species, Catus. It just adds a US to cat. And after Linnaeus, since the 1700s, scientists have discovered millions of living things. Oh, Mom, Felix the cat. You're so close. I love that guess. Good guess. But many of the plant and animal groups he named are still used, as well as his binomial method. Megamouth sharks were discovered as recently as 1976. It was given the scientific name Megachasma pelagius. And this guy says, "Hello, I'm new to science." Okay, so that about does it for our chapter on living creatures. This was the story of science. And now, one of my favorite books. This is a Lift the Flap book about the periodic table. And before Storytime went live, I went through the book and I opened up all the flaps. Does anyone else get really nervous when they open the flap for the first time? I didn't want to rip my new book. So I'm going to use a pair of tweezers to help me open the book so that I don't rip anything. Now, the periodic table is where scientists list all the new types of atoms and all the atoms in the world. So, atoms are little teeny tiny building blocks that make everything in the whole world, even you and even me, and even this book. So this book is going to show us different types of atoms and where they belong and what they're used for. And we can get more into this, so if anyone has any questions, this is a kind of a complex topic, but we're going to try it out. Okay, let's start with, what is the periodic table? Everything in the universe is made up of building blocks called chemical elements. Can you say that with me? Chemical elements. They clump together to make everything from specks of dust to whole planets. Wow, that's a lot of atoms. There are 118 elements that scientists know about so far, and these elements are often shown together in a grid called the periodic table. It's not a table that you eat off of, it's kind of like a table of contents. Remember that list where you could find everything in a book? It's a little closer to that. So, let's see, the best way to do this is, I think we're going to put it on the music stand and put the music stand a little bit closer to you. So, beep, 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 beep. Raising it up. Okay. The light might give us some issues here, but that's okay. We're going to try our best. Whoops. We're coming to you live, folks. This is the beauty of live television. Okay. So, maybe I could try to move it away from the window light. Oh, this looks better already. Excellent. Thanks for your patience, everybody. Okay, so we're going to start on the yellow side here. And she says, hello, I'm an element. And she's wearing the block that says carbon C. Each square character you see in this book represents one element. We've got tin, gold, and oxygen. This is the periodic table. Each box on the table represents one element, and all the elements are different. Most elements are found as solids, like this book. Solid looks like me, carbon. That's a solid body. But elements can also be liquid, like me, francium. Liquids are kind of like something that you could drink, like a water, juice. Those are all liquids, things that take the shape of their container. Or gases, like me, and that's chlorine. Are we talking about the same kind of gas that you sometimes might get after lunchtime? Oh yeah, but that's called methane and it's really stinky, but breathe in. You just filled your lungs with a gas. This table was invented by me, Dmitri Mendeleev, 150 years ago. Look for me throughout the book. There's Dmitri. Scientists have given each element a name and a short code name. My name is carbon. My code name is C. Some elements are very common. We've got iron, and iron. There's more iron in the earth than any other metal. Others, such as these, are incredibly rare. Francium, astatine, and polonium. I only occur as tiny traces in rocks. Each element, just like you, has a unique personality, how it looks and how it behaves. The periodic table groups elements together that have similar personalities. For example, iron, cobalt, and nickel are all magnetic metals. We're all the same color because the table in this book is color-coded. The color of our bodies on the table tells you a little bit about what we're like. I'm a hard and shiny metal. That's the gray ones, and the orange ones say I'm a poisonous gas. Yikes, we should stay away from that one. Okay, now we're going up to the orange page here. Elements are all made up of incredibly tiny parts called atoms. My atoms are different to the atoms of other elements. Oh, carbon's back. What does carbon have to say? All my atoms are iron atoms. All of my atoms are chlorine atoms. A tiny lump of any element is made up of billions of atoms. Inside every atom are much, much tinier parts called protons, neutrons, and electrons. Lift the flap to look at an atom. Wow, and there's what the parts look like. Let's see, I could lower this a little bit. So we've got our protons in blue, neutrons in red, and yellow is electrons. Now you can't see these with your own eyes. You would have to look under a really, really powerful microscope, like scientists might have. Oh, hey Sam and Alex, thanks for joining us. Okay, moving over here. The number of protons in an element's atoms is what makes that element unique. My atoms have 6 protons each. Each atom is very small. There's our friend carbon again. 6 protons and 6 neutrons. That's a nice balanced number. My atoms have 17 protons each, so they're bigger and heavier than carbon's. 17 protons and 17 neutrons. Some things are made of atoms from just one element. Diamonds are entirely made up of carbon. Ooh, who loves a good diamond? Diamonds are a girl's best friend, but hopefully they're cruelty-free. Carbon. Lots of jewelry is made entirely of silver. Most elements prefer sticking together to being on their own. Often, elements are jumbled together in a mixture. Rocks are mixtures of metals, such as iron and aluminum. So there's one of our iron friends, that's gray. And there's an aluminum. Ooh, we haven't seen any purples yet. Oh, there's our friend Dmitry Mendeleev. Mixtures aren't chemically joined together. They can be separated to get at their individual parts. And inside, you can see that there's a bunch of iron and a bunch of aluminum. Cool. Sometimes elements fuse together to create a compound. When I fuse with iron, says oxygen, we turn into a compound called iron oxide, which is also known as rust. In this book, compounds are shown as hexagons, split up into the elements that form them. So it's half iron, half oxygen. Wow, it's almost like a superhero. Oh, there's our friend Dmitry again. When elements touch each other and fuse, it's known as a chemical reaction. Iron oxide has the code name Fe2O3 because rust, or iron, contains 2 atoms of iron for every 3 atoms of oxygen. So it says iron 2, oxygen 3. The elements in compounds are chemically fused together and are often hard to separate. Ooh, it looks like Dimitri's having trouble separating them. Turn the page to find out how the periodic table works. Okay, here's the full table again. Oops. Hang on 1 second, folks. Just want to make sure that my other camera for behind the scenes can get this as well so that we can check it out later. We're always learning when we're doing things live, aren't we? Okay, so let's check out that periodic table. Okay, here we go, we're back. The periodic table. Okay, the periodic table looks like this. It shows 118 different elements and reveals which elements are similar to each other. Remember how they're sometimes color-coded? There's our grays, purples, we've got our blues, greens, and each area has a different name. Hydrogen is the first element. The table is numbered from left to right, just how we read. Under hydrogen, it says the elements are laid out in order of how many protons their atoms contain. Hydrogen is first because its atoms have 1 proton and 1 neutron. So look, when she opened up her little square tummy, you could see the protons and neutrons. Cool. All right, what does each box mean anyway? When we look at a table of elements, there's a number in the corner. That's how many protons there are. We've got a big letter in the middle. That's the secret code name. And then at the bottom, we've got the full name of the atom. And then right here, the bottom number is the atomic mass. That's how heavy one atom of this type would be. So when you step on a scale at a doctor's office, that would be your mass. Okay, let's see. What order should we read this all in? This is so much fun. Okay, let's check out our friend Mendeleev again. Mendeleev saw lots of patterns in how the elements behaved. The patterns were so clear that he left gaps in his table where he knew undiscovered elements must fit. This is what Mendeleev's table looked like. So he knew that he couldn't find them, but he knew that someone else would. That's why in science it's so important to share our results so that all scientists can see. Okay. An element's code name, member, or its letter, is called its chemical symbol, and it can be quite different from the name. So tungsten, you would think it's a T, but it's actually a W? That's weird. This is because many code names come from other languages, especially Latin and Greek. Okay, let's move back over here. Each element contains 1 more proton than the one before it. That's why each number goes 19, 20, 21, 22, 23, 24, each one adds 1. So let's open up this one. The middle section of the table contains hard, shiny metals called transition metals. Turn to pages 7 to 8 to read more about them. It's like a table of contents in the book. That's fun. This group of elements on the bottom is in a small grid underneath, and it's really to help make the table a little bit easier to read. Let's see. A lot of these elements are dangerously radioactive. Find out about them on pages 15 and 16. This is what the table would look like if you inserted them in the grid. So it would make it a little too long, so all of these are at the bottom. And guess what? This is really cool, one of my favorite parts. The periodic table is used in every country, and the code names are the same in every language, even when their full names are different. So we can share our results with lots of different scientists, and they'll know what we're talking about. Okay, we've got 1, 2, 3 more flaps to open, and then we're going to come back to this book on another day. Hey Alex, I'm so glad you're here just in time for Elements 113 to 118. They were officially discovered in 2015 and named in 2016. Lift the flap to learn about them. There's a chance that there's more than 118 elements, but they haven't been discovered yet. So the ones that were discovered in 2015 and 16, which isn't that long ago, are Nihonium, Flerovium, Moscovium, Livermorium, Tennessine, and Oganesson. So if you discover an atom, you get naming rights. So my guess is that whoever discovered Tennessean came from Tennessee, and whoever discovered Moscovium came from Philadelphia. No, I'm just kidding. They probably came from Moscow. Okay. So we open that one. Oh yes. Now, on the very bottom, these are more elements that some famous scientists discovered. And I want to make sure that you could see this. Let's see. The sunlight. I love it. I love it. But it does make it a little complicated. Okay. So, curium. Anyone think they know who might have discovered curium? Are you curious? It was Marie Curie. You might know Marie Curie for also discovering radium with her partner. Then we've got Einsteinium. I know who made that one. The Bagel Company. No, just kidding. It was Albert Einstein. How about fermium? I actually am not sure about that one. Fermium is Enrico Fermi. Oh yes, how could I forget about Enrico Fermi? Then we've got Mendelevium, which is, there's our friend again, Dmitri Mendeleev. He made the table of contents. And then we've got Nobelium. That's from Alfred Nobel. Ooh, Nobel. And the last one here, Lawrencium. Oh man, that's not a flap. But I bet it's someone named Lawrence. That's just my guess. So, if you really liked reading this Lift the Flap book with me, then make sure you write in the comments that you want to see more Lift the Flap. I am going to be regularly live streaming on Mondays, Wednesdays, and Fridays at 2 p.m. And then, just like today, if I have some extra books to read and some extra time on my hands, I'll come at you as a surprise, but I'll try to warn you first. So, my name is B the Scientist, and now it's time for our goodbye song. There's a lot of first-time viewers here today, so we need to show them how it goes. You might remember this goodbye song from one of my favorite kids shows, Out of the Box. So long, farewell to you, my friend. Goodbye for now, until we meet again. So long, farewell to you, my friend. Goodbye for now, until we meet again. It's been great to play and read together in the hive, but now it's time to say goodbye. So long, farewell to you, my friend. Goodbye for now, until we meet again. For more information, check out BeTheScientist.com.